Hello there, math fans. Dr. Andy Lovelace. One of the things I've gotten into to try to bring the material more alive is to make animations. The last time I taught this course, I didn't do that. And so for my students, if you're doing a homework question and you're like, I'd love to see an animation of this, let me know on the discussion board. I'll make it. Here's one memorable question from the homework, this Erik's disabled sailboat. It's a question about imposing coordinate systems and using speed and distance and time. But you can read it there. It's from the homework. But we have the disabled sailboat out here in the Puget Sound. And there's a ferry going from Kingston to Edmonds. Now, I live really close to Edmonds. I live in Mount Lake Terrace. I've taken this ferry many times. They have really nice donuts on the other end. They just opened a new place that has empanadas. But I've always wanted to make a visual that goes with this. So here's my animation. And what I like about this is it shows you that to make this animation, I had to do all this precalculus. For some students, that's kind of a new thought. And so I'm happy to show you how to do this, but you basically have to be able to do the precalculus to make the animation. So it's another dimension to why this might be interesting. Okay, so what have I done? I've put Erik on his little dinghy. There he is right there on the dinghy. And then I've put the ferry boat. And then later in the question, it asks about a police boat following it. Okay. And then I found the equations for everything. I converted it to seconds. I got everything just right. And then I was able to type them in. And the cool thing about this calculator is you can just hit play and it will move them. So you can see the dinghy has started to go. He's going straight south. His sailboat has been disabled. And so he's seeing if he can catch that ferry. And that's the question you're going to answer. So your job will be to label the changing locations on there. And it's really just speed is distance times time. It's just the time is a variable now. But you need to label it in relation to everything else. So it feels like a lot, but I think this makes it more interesting. And then later in the question, it says there's a police boat back here. Now, the police boat, I had to make it a Lego boat because my son's so into Legos. So the Lego boat's going to try to catch up to the ferry boat. That's another part of the question you're going to answer. Do they meet? What happens? How do we find the equations? That's it. So there you go. Those are the sorts of animations I'm very happy. Any problem that has to do with motion, I'm very into making this. During the pandemic, I pretty much just made animations to try to convince students to come to my Zoom sessions. So I'm happy to make those. And I'll make some more of them in the time ahead. So I'll just make a couple comments for those that actually want help with the question itself. When you read a lot of information like this, we're going to do all the same sorts of stuff. We're going to, what are we given? What do we want? Can we visualize? The added step here is to give a coordinate system. When you read the question, it mentions several different things measured off of Kingston. And so that's why, in my opinion, I would pick Kingston as the origin. There is nothing that says you have to do that. And I would label this north, east. Never eat soggy Wheaties. Students tell you waffles to me. But that's your choice. This is more realistic. It says that this is 3 miles over and 2 miles up. It says that this is 6 miles over. So I'm making a choice to do things in miles. And then they give you some sort of speed for the ferry boat. Let's say and you can see, I'm hoping you're getting more and more comfortable just labeling everything. So you have some way to talk about it. It tells me something about Erik, that he is going 10 feet per second. And they both start at the same time. So the unknown here really is the time. So there are choices to make. But in a moment, once we can make some of those choices, the real thing that we're trying to do is label where will the ferry be at a certain time, and where will the dinghy be at a certain time. And so if you think about labeling those, this one starts at 0, 0. One of the coordinates is never going to change. The y coordinate's going to be 0. So the only thing we're trying to figure out is what that is. This sort of geometric reasoning is very important in calculus. When I teach calculus 2, I know a lot of students have a lot of trouble with this. So it's a great opportunity to practice this. If you were going to just leave it in miles per hour, you could just label this 12t. So think about how I'm getting that. But the moment you do that, time is now in hours, because I decided to use this. If you didn't want it to be in hours, you would convert this, and then your time would be whatever it is. If you wanted to keep it in hours and miles, you would need to convert this to miles per hour. Those are choices you have to make, and they're all correct. You just might look at the rest of the question to decide. So there's still this lingering problem of getting units to match when you start a problem. So I'm not going to do that part, but I just wanted to talk about the sailboat. So the sailboat is starting up here at 3, 2, and it's heading south. So if you think about where it will be after a certain amount of time, you have a way to get the distance. Distance is speed times time. So if you're going to use feet in seconds, this distance would be 10t. Then t would be in seconds. So you're going to need to convert and choose one, and then whatever number you have, you can put that here. But that does not tell you the location. The location will be 3, and then think about what this will be, 2 minus whatever that distance is. So I feel like that's the skill. Currently it's not correct because I'm not using the same units. But that's, to me, the big skill, is being able to use our speed and distance imposed on our coordinate system, and then be able to ask questions like, when are they equal? All right, I hope that gives you a little start to that question. And another dimension to something I'm offering. If you ask me to make an animation for a problem, I'll probably do it. All right, thanks for listening.